and look at them. Okay. So again, multiple choice questions, part A, unit 8. If they're giving me acceleration, what is the net change in velocity? So then I'm going to do from 1 to 5 of the velocity, VT, or I'm sorry, the acceleration, not the velocity, A of t dt. Okay, so I have 1 to 5 of natural log 3 plus t to the 4th dt. Okay, do not make the mistake and think this is the antiderivative of natural log is 1 over u. That is false. Okay, that is not true. The antiderivative of 1 over u du is natural log of u, but it doesn't go the reverse direction. Okay, so that's one thing I want to point out. If you have an integral of a natural log function, it is not 1 over u. Okay, it's, I'd have to look again, I'm rusty on it. It's like 80 to the u natural log of a, I think. Still look back at that. Okay. All right, so this is one that's kind of nasty to look at, but this is a with calculator problem. Okay, all right, so this is with calculator. I'm going to go ahead and just put this right in my calculator, and it's kind of hidden back here. I'll get rid of this. So I put this into my calculator, and I got this as an output. Did anybody else get this as an output? Error, non-real results.
I did that.
Okay. Okay. If you have the CAS calculator, CAS it's perfectly fine. You can use that in the AP test. Okay, no penalty if you have that CAS. But that CAS will always give you answers exact. So like 2 pi, 2 root 3, like they'll give them all to you exact. So that's one benefit of the CAS calculator. Okay, but here's a hindrance, like on the yellow, just the regular CX2, CX2 non-CAS versions, it will work. But on the CAS ones, it won't. Okay? What you need to do is if you put a decimal point, say after the 3 here, then it will work. Okay? So if you were using a CAS calculator and you were getting frustrated by this point, like, why won't it do this? It's telling me error, non-real result. Okay? What it's taking into account is you can't take the natural log of a negative number. I mean, there's really no way to get this as a negative number, so I don't know why it's saying non-real result, but something's going on in their computations and their processing in the CAS calculator that's throwing it off and saying, nope, can't do it. Well, we can kind of go around it. We can approximate what it's going to be by putting a decimal point after one of the numbers, and then it will give you a decimal answer.
So was it like a hard trial calculator?
Correct. So I spent like probably 15 minutes on this question, and I was like, why is this not working? Because like it's not one that I wanted to do by hand, so I kept putting it in the calculator. I was graphing it, I was doing all kinds of stuff to it, and then I'm like, wait a minute, and I tried that, and it worked. Okay? So if you have the CAS model and you get this non-real result when you're trying to integrate, put a decimal point after it, and you're good to go. Okay? So this one ends up being this 16.868. Simple as that. Okay? If it's a with calculator problem, you don't always have to use your calculator, so don't think when you get to the with calculator portion of the AP exam, all right, this is with calculator, I need to use my calculator on this. No, don't think that way. There's a lot of them that you can do without a calculator, but sometimes if you can do it quickly with your calculator, yeah, just punch it in and away you go. All right, next one, question number 3. Again, I have like 5 or 6 that I'm going to take a look at out of these. What is the area of the region in the first quadrant bound on the left by the graph x equals? So whenever you see that x equals, that should throw up a red flag right there, or at least throw up a flag. Okay, I know I'm going to be integrating with respect to y. So if they ever start out the problem as x equals, you should automatically think, okay, I'm probably going to be integrating with respect to y. Okay, and so this is y to the 4th plus y squared. This is just the graph 5y. I'm trying to find this region here. So my bounds go from here up to here. So my integral will be from 0 to 1.516. Okay? So make sure we are doing our bounds correctly. Sorry, that's in your way. Make sure we're doing those bounds correctly and we're not doing it along the x-axis. So this is really the biggest thing I want to get out of this one. It's with calculator, put it in. The right line subtract the left line, so 5y minus the y squared plus 2. And this one gets your answer of A. Okay, number 4. So this one has the regions bound by the graph, y equals 4x, so that's our linear one. Or this one, I'll just write over here. And then x minus x squared plus x cubed are shaded in the figure. So I graph this as well because we need to know these points right here, where it's crossing at. Okay, so this one, we're going along the x. It's probably hard to see, but it's 1.303 is the x. And over here, it's 2.303 as my x over here. All right, so my integral is going to be a combination of two regions. So I have this region, but then I also have this region. So the first one is negative 1.303 all the way to 0. And we can still do top line minus bottom line. So this blue subtract the red, or the straight line. Okay, and so my curved one was the x minus x squared plus x cubed minus the other one, which is 4x dx. So that will give me region 1. Okay, so there's variation on this. Natalie.
Why do you use the curved line? Because I thought we talked about like the furthest away from the x-axis. Why would it not be 4x?
So just a regular integral. If you were doing an integral, say, for the area with this this diagonal line, your calculator is going to spit out that it's a negative of the area. So you're going to get a negative answer. Okay? And so if you treat it as, even if it's below, top line minus bottom line is going to kind of negate that negative coming out of it. So it's really going to get you, it would still work, but it's going to give you, if you did it the other way. So like Ian did it, he did his from 0 to negative 1.3. So he went this way. Okay, so he changed the bounds so it made it negative. And then he did it that way, but it was a negative of negative, so it made it positive. Okay, but if you want to just think always top line minus bottom line, and I know when we were first talking about this section, I said that. Okay, and now looking back, I'm like, well, yes, but I don't even do them that way. I always, so if you remember, treat it as top line minus bottom line, it works every time. Okay, and then you can just keep your bounds in order. So that would be region 1, and then you would add region 2, 0 to 2.303. Now this is 4x minus x squared plus x cubed dx. Add those together. A second option on this one. We know that this is below. Okay, so, nah, I'm not going to say that. Treat them as separate ones like this, top line minus bottom line, add them together, and you're good to go. All right, so this one's ended up being the 6.083. All right, number 6, the average value of the function f on the interval from 2 to 6 is 3. So I need to interpret that very first statement. The average value of the function f on the interval from 2 to 6 is 3. So what this is saying, the average value, 1 over 6 minus 2, which is 4, of my integral from 2 to 6, some function f of x dx is 3. So I need to take that information first. Okay, so if I'm doing the average value of something and it equals 3, well, that something had to be 12. So if I take 1/4 of 12, I get 3. So I know that something is 12. Now they want us to use that, and they say, okay, what's 2 to 6 of 5 times f of x plus 2 dx? Well, my integration properties allow me to bring out a constant multiple of 5. And I could separate this into 2 separate integrals and write it as 5 times my integral from 2 to 6 of f of x dx plus my integral from 2 to 6 of 2 dx. So this becomes 5 times, I already know all of this is just 12. My integral from 2 to 6 of 2, you can think about this a couple ways. You could think of it, well, if I integrate, this would be 2x evaluated from 2 to 6. Or you could also think of this, well, if my function is 2, this is that line y equals 2, from 2 to 6 creates a rectangle going on here, which is a 4 by 2 rectangle, which is 8. You can think of it that way. Okay? Same thing would happen here. 2 times 6 is 12. Minus 4 would get you 8. Or you can think of, okay, the function is 2. That just creates that rectangle. I know my integral represents the area under the curve. And so I have 60 plus 8 to end up with 68. All right, so this is one of those little extension type properties that AP will throw at you, or extension problems that AP is going to throw at you. Okay, don't discount what they say, like the setup to the problem. Don't just glaze over that and automatically jump to, okay, I'm trying to figure out the integral from 2 to 6 of 5 f of x plus dx. Don't jump to that. That's kind of a part B. You got to first figure out part A. When we figure out part A, the integration piece is 12. We can use that. Okay, this next one. So this one is a little bit different, but this is playing off of what we know. So they give us this curve. It says the interval from 0 to 10, particle moves along the x-axis. The graph of the particle's velocity, so we know we're working with velocity. At time t is shown. The particle's displacement. Okay, so displacement we know is going to be the integration of our velocity function dt. And so displacement is taking into account areas. If I want to find the area under the curve from 0 to 10, okay, I'm going to take my negative plus a positive plus my negative and combine all those together. So if we use the variable a for above, and then I'm going to subtract out b for anything below. So if I say 15 is going to be the sum or the difference, we'll think sum adding a negative, of the area above and the area below. Okay, that will equal 15. And then the particle travels a total distance of 73. So distance is going to be equal to the absolute value of my velocity. And they tell us the distance is 73. So I can think of 73 will be my area above, and then I'm going to add my area below to this. Okay, because I'm not going to treat the area below as a negative, so I'm going to take all my areas and add them up. So we know displacement will be 15, but then total distance will be 73. Now this becomes a system of equations. Okay, so if I set this up, I could say, well, 15 plus b is equal to a. So I'm going to use that down here. So I'm going to say 73 equals 15 plus b from up here. So 73 equals 15 plus 2b. Subtract 15, I end up with 58 equals 2b. Divide by 2, I end up with 29 is equal to b. And the reason I'm doing it in terms of b is because b represents below. Moving left is below. So 29 is my below piece. So this one was definitely an extension question. understanding displacement, understanding distance with respect to velocity, understanding an integral represents the area above, area below, because they don't give you a function. So you can't do this one by hand, or you can't add up the areas or anything. And setting up this system of equations is something different. We haven't done any problems like this. But with them showing it, this is definitely fair game. Okay, and then question 9, I think this is the last one. Nope, 9 and then 13. The velocity of a particle, so they give you this v of t function. Which of the following gives the total distance traveled by the particle over the interval from 0 to 3? All right, so distance, I want the absolute value of my velocity function. Okay, so total distance on here. We have to look at the options they give us. So this is kind of multiple choice strategies. Okay, looking at these multiple choice options, which one makes the most sense? Okay, I know it's not C because this is displacement. Okay, so it's not going to be C. Okay, it's not going to be the first one. But let's actually break down what's going on here. Okay, total distance traveled. Well, let's figure out first, when does velocity equal 0? Okay, so if we did a quick sign chart and we're going from 0 to 3, and again, our velocity function is e to the t minus 1 minus 1. Okay, I know at 1, it's going to be equal to 0. Or you don't even have to put a dot on there. I'm just doing that to emphasize. But we know at 1, it actually equals 0. So I'm looking on the interval from 0 to 1 and 1 to 3. Well, if I pick a smaller number in here, like if t is less than 1, I'm going to end up with a negative exponent. And so it's 1 over e raised to some exponent, which is a really small number. So whenever my denominator is bigger than my numerator, it's a really small number. So I have a really small number, but I'm subtracting 1 from it. So it has to give me a negative number. And then if I'm above 1, say I'm at 2, I would have e to the first minus 1. E is 2.73. So subtract 1, it's going to be positive. So I did a quick sign chart here. So I know that when t is less than 1, my velocity is less than 0. So it's negative. And then I know when t is greater than 1, my velocity is positive or greater than 0. Now let's take a look at what our options are. So we know that on this interval from 0 to 1, our velocity, this piece is going to be negative. Okay, we know this. Okay, but since they're asking for total distance traveled, I want to negate that negative by putting a negative out front. Okay, we know this is negative, so I'm going to negate it by putting a negative out front. And then also I'll add from 1 to 3, this will be positive, so I don't have to worry about that. So I don't have to worry about any negatives or anything. So that matches up with this one, letter D. So on D, where they brought out this negative sign, the negative is negating this piece, which is negative. We want it to only be positive because we're looking at total distance. All right, and then 13. So 13, oh, I thought I graphed this one. Let R be the region between the graph of y equals ln of x. So this is nice to know, because this is a no calculator question, that we need to know what a graph of ln of x looks like. It's crossing right here at 1. And the line x equals 5, so it's going to be right over here somewhere. X equals 5. Which of the following gives the area of the region R? So this is the region we're looking for. This is a no calculator question, and so they're going to expect you to know what the graph of natural log of x is. All right, and graph of natural log of x always goes to the point 1, 0. So if I was doing this, as soon as I looked at it, I would say, okay, I'm just trying to figure out all of these rectangles, and I'm going to integrate from 1 to 5. Well, my answer choices, they've all written these in terms of y. So if I were to do it, I would have done vertical rectangles, but they're not even giving me that as an option. So they're saying, nope, you have to use horizontal rectangles. We're making you do it in terms of y. Okay, so y equals ln of x. If you raise both to the power of e, you end up with e to the y equals x. So now that's our function, e to the y equals x. And we're trying to find that rectangle right there. And so we're going to have the entire distance is 5. So our entire distance here was 5. And then we're going to try to subtract out, or we will subtract out, this shorter distance, which is just e to the y. So 5 minus e to the y. My integration is now on the horizontal axis. So this right here, this point, let's get this green line out of there to make sense. So we need to know what the y value of this point is. Okay, well, the y value of this point, if this line is natural log of x, at 5, it would be natural log of 5. That would actually give me the value. So it's this one, letter C. So my bounds go from 0 to natural log of 5, 5 minus e to the y dy. So these are the ones that I guess stuck out to me that were a little bit different than what we've been doing. Not different, just extension of what we've been doing in class. And these are the types of